This is an example that I showed in class of an acetal hydrolysis, and the acetal that we're going to hydrolyze is this one right here. So the alkoxy group is actually what we would call a bridged alkoxy group, and we have a carbon that is singly bonded to an oxygen, singly bonded to a second oxygen, and there is an implied hydrogen here because we've written this in bond line notation. This is an acetal, just as the other acetals that you've seen, because you have a carbon singly bonded to two oxygens. In order to do the hydrolysis, we're going to add water, and we're going to do this in the presence of an acid catalyst. So as I showed before, the carbon that's singly bonded to the two oxygens, or has the acetal bonds, that is the carbon that will become the carbonyl. We will be breaking this bond, we will be breaking this bond, and so we will have two alcohol functional groups. It just so happens that the two alcohol functional groups are connected to each other. But this is part of a carbon chain. We don't ever break carbon chains, so we don't have to worry about that. So the main carbon chain has the carbon that has the acetal bonds. That will become our carbonyl. So I'll draw that first. It's a 4-carbon chain, and the carbonyl is simply a carbon double bonded to an oxygen. So we are making an aldehyde here. And when our bonds break, and we now are going to form alcohol groups, the alcohol that we form will look like this. This is an example of a diol. It has 1, 2, 3 carbons. So this would be called 1,3-propane diol. You could also draw this 1,3-propane diol like this. One, two, three. Because these bonds right here, each of these carbon-oxygen bonds, the carbon-carbon bond and the carbon-oxygen bond, all have free rotation. And so this is an example of how this could look. It also makes it a little easier to see where it came from when the acetal bonds broke. So we hydrolyzed this acetal, we formed an aldehyde, and then we formed our two alcohol functional groups that are on the same molecule, so we formed a diol.